Hi everybody, we'll start. My name is Aurélien Pupier. I'm working at Bonitasoft. We are providing a business process management solution. And today I will explain you how we were able to build our Eclipse RCP application 3 times faster than before. So I will explain what is the context, what we are building exactly, from where we start, and then where we are now. And after that, I will explain how we were able to improve this time. Also have some ideas to go further, so I will share them with you. So the first thing, what we are building 2 RCP products. In fact, there is a community edition and a subscription edition which is based on the community edition. We are providing it on 7 languages. We are providing this product available for 3 platforms on 32 bytes and 64 bytes, and also on all-in-one zip, which is able to run on each of these platforms. And this product is 4 years old, more than 4 years old. So it means that we have more than 100 plugins. We are delivering 70 gigaoctets of files. We are on support over years, so it means that we need to be able to provide a maintenance release of our product after several years. We are using a bunch and integrating a bunch of Eclipse projects, and also Tomcat, for instance. All of these projects are embedded inside our Eclipse applications. So we have more than 200 and thousands unwritten line of code, and we are generating 60,000 lines of code. We are using modeling approaches with a generative approach. And we are using JUnit and SWT bot for the test part. So at the beginning, what we have to build and test all of that is we have a virtual machine containing Nutson, which is building our other components. And we are triggering our RCP builds on a dedicated virtual machine, which is working on Hudson Slave, which is using the other Bonita components built on this machine. And we also have another machine, Mac one, in order to generate installers for Mac, the DMG. So with all of that, it takes us almost 4 hours to build and test everything for our 2 products. That's quite a lot. Now we are able to build it in 1 hour and 20 minutes, build and test. And we have a far more simple architecture. I will explain more in details after how we can get rid of every other thing. And, the logo that you can see. So the first thing that we have done in order to be able to deliver in less time is that we took time to improve it. So we didn't do it all at the same time. It was to work on the everyday work during 1 year, and now we also have a dedicated part-time build engineer that is helping us to continue to improve it. Yeah. So the first thing that we have done is that we migrated from the PDE build to Tyco build. In fact, this move was not the things that help us to have a faster build, but it opens possibility to have faster builds after. We were able to have modularized build. We were able to ask help to more people, more developers in the company because it is based on Maven. And we are not only 2 guys in the company that are able to understand the PDE build. Now we can ask help to other people. And it was also easier for the Bonita community to understand the build and be able to build our open source version. So, as I said, Tyco brings us some modularity. So, our Eclipse application is OSGI based. We have modularity, and with PDA build, it was harder to build only a subpart of the plugins that we want. With Tyco, it was really easier to do it. So with that, now we are no more building everything from scratch. We are some parts of our projects are built only on demand or on nightly basis. So we gain time here, for instance, for the translations. We are using fragments, and we have 6 languages. So as we have 100 plugins at the beginning, we have at the end we have 600 fragments to build, and it takes some time. So we are building them only when there is an update from our online translation manager. We also avoid to build our patch plugins. There are not a lot, but this is something that is not changing every day. When you are patching plugins, I hope that you are doing it one time and you don't patch anymore after. Also, we are using a generative approach in our modeling project. So we are generating code at each build. So now we are generating the code only when the model is modified. At the beginning of the company, we were modifying the model almost every day, so it makes nonsense to do it. But now we are modifying the model only perhaps once a month. So now we are building once a month this part of the code. And also, we are no more generating installers for each platform. We are building only the zip file that you can use on every platform in the pipeline, and we are building installers only on a nightly basis in order to save time, because with the zip file, our QA tester or developers are able to test the build, the final build. They don't need all the installers every time. Another point that saves us a lot of time is that we are using a mirrored target platform. It's incredible the time that can save, even if you have a really fast internet connection, because at the other side the server can be done or can be slower. So you have all locally, and it's really faster. It's also a good thing for long-term support, because sometimes remote update files are changing, or they can be done. So after several years, you will be able to still build your product, and you stay the master of of your build. You don't have external dependencies anymore. Another thing, in the first schema, we were using virtual machine. Why we were using virtual machine? It is because like that we have a backup of our build system, and if something, if a machine is crashing, is burning, we were able to recreate it somewhere else and have our build available. So, but what we saw is that in the Eclipse build, there's a lot of I/O access. Using the virtual machines kills the performance of our SSD hard disk. So we try to use mounting partition for the VM, to use some logical unit of virtualization and so on, but every time the using directly the hard disk was really faster than using the virtual machines. So we get rid of virtualization. But the problem is that we had no more backup. So we have to find another solution for this point. And for that, we are using Puppet. So with Puppet, we are describing, this is a simple script that is describing the system on which you want to build. So it will describe the package that you need, the Java version that you need, the Git version that you need, the Jenkins version that you need on your system, on everything that you need to build your project. And also, we are storing this configuration on Git. We are also storing the Jenkins, Hudson Jenkins configuration on Git. So like that, we are able to, just by launching the Puppet script, to recreate our Git environment, and we are ready to rebuild our system. And help us to have less downtime, because when to backup the virtual machine, we had to stop it, to copy it to another machine, and it takes several hours. And it was really bad. So now we are just backing up a file, and no downtime on this side. And also, there's something very important, is that using Puppet is easier to modify the environment of your build system. So if you want to test another thing, or to test on another machine, it's really easy. You just modify your script, launch your script on another machine, and you can test if using more RAM is more effective, or you're using more powerful hard disk is more effective or not, or what is influencing more the build. So like that, we were able to see that the bottleneck was the hard drive, the I/O access. It was really important to test, to be able to test in several environments and modify it easily. On totally another way to improve the time that you need to build. You are using Jenkins scripter plugin. This is a plugin that is providing domain-specific languages to describe how you are orchestrating each job of your build. So like that, it allows you to have more complex build flows. We were using before the build pipeline plugin, but there is not the Gen plugin was there wasn't a good integration with the Gen plugin, so we were not able to do exactly what we want, to trigger the build exactly what we want with this one. With downstream, upstream way of doing them, it was hard to see the global thing, to modify the build chain. It was quite hard to have a global overview. So using scriptler, it was easier also to test only a small part of the tool of the build chain. So we were able to test faster a third part. No need to rebuild everything, because with scriptler you can just comment a little part of the script and launch the other a third part of it. That's really easy to do. Something that you can do easily with pipeline reading, for instance. Another totally other way to get faster. Don't sleep. Just don't sleep. In your test, in SWT bot, but I already saw it with Selenium test or even genuine tests in multi-threaded environments that are using 5.sleep. When you are waiting for something to be done, you need to have conditional wait and check more often than just at a sleep of 1 second or 5 seconds, because like that you are sure that it will have time to be done. Yes, by removing all the bot.sleep, we were able to gain several minutes in our test. Because in some factorized place there was some bot.sleep, and we saw that it takes 2 seconds for every test of them. And so yeah, bot.sleep is, you really need to avoid it and use conditional wait. It also helps you to have more, to gain stability, because if you want to build on another machine that is slower, it won't work, or faster. We also have issue with faster machine. It doesn't work because the weight was not good, and we sleep too long, and the test was broken. In order to check if you have tests that are taking too much time, you can. The first thing to do is to go to the Hudson view, and in the reports, G-unit report test, you have the list of the test and just the duration. And for instance, for us, we noticed that for a whole bunch of tests, it always takes at least 3 seconds. It was because in the factors code there was 2 seconds waiting, so we remove them and we 2 seconds. A little thing, but now we are generating the GMG directly on the Linux machine using Gen ISO image. So like that, we don't need anymore another slave. We avoid the transfer of the whole application between two machines, the copy of it. So we gain some time and simplicity in our build. So I showed you several things to help you to get faster, but the real important things, in fact, whatever you want to try, is that you need to fail fast, to have a way to test the third part, to know very fast if the thing that you are changing will bring benefits or not. In fact, there was one before it takes 4 hours for us to build everything. It was mostly because when we were touching the build, we have to wait all the chain to be done before knowing if if we break something or if we improve something. So we didn't do a lot of time because we know that it was very time consuming. Now that we are using Scriptler or Tyco, we are able to test a subpart of our build chain more easily, and like that we are able to test more things. That's really the most important thing to remember. And also, yes, using Puppet, you are able to test in another environment. Test if your build is faster using Java 7 or Java 6 or Java 8. Test if it is faster on Linux or CentOS or on Windows. As you are able to test it quickly, it's very easier to go to the wrong to the good path. So some few other ideas after that. There is still about Tyco, the target platform resolution is taking quite a long time. I'm pretty sure that there is a lot of improvement that we can try to do in this way by caching the resolution. I don't know, but it's not easy to do because it's tightly tied to Maven, to internal system of Maven, but I'm pretty sure that working with Tyco will help to go faster. There is also something that we didn't do it for our Eclipse part, but we are doing it for our execution engine to split some slow fast tests and running only fast tests every day. The question after is that, do you have enough confidence in your smaller set of tests, or do you really need to play them all in order to be sure that 100% sure that you don't break something? After playing the whole thing, it's just a matter of just to be sure that it works in every environment. Another thing is for the translations, we are building only fragments. This is very simple. For that, there is a target platform resolution that is taking a long time. We are thinking to use something lighter and generate ourselves the correct manifest HTML and generating the jar without using Tyco in order to avoid the target platform resolution, because there is less risk at our eyes to do it for these simple artifacts. And also, something that will be great is to have real workflow integration in Jenkins in order to orchestrate your jobs in Hudson, because currently with Scriptler, this is not very graphic. You have to read the script, so not as easy as we want. You can't put all conditions that we want in the flow. So, if we can integrate our solution, for instance, in Hudson or Jenkins, to have a real workflow with conditional triggering and so on, it will be a very good thing. So, do you have questions about it?
So this is talking about RCP testing, right?
Yeah.
So can you describe what kind of testing framework are you using? You're using the Tyco plus SWT, or using the Eclipse plugin testing, or whatever else?
We are using the Tyco Eclipse plugin test. I think that I didn't understand well your question. Can you repeat, please?
So basically, everything Tyco plus SRT for the body type, right?
Yeah.
Can you show, can you maybe show or say more about that the puppet setup that you're using for your CI machine?
You want to see a script?
Do you have something to show about this? Because it's something that I haven't seen at all, so it's very interesting.
I don't have it in my own, but I can show you after. Yeah.
So regarding the target platform layer, so do you using the Nexus or Artifactory or the other thing?
At the beginning, we plan to use an Artifactory manager and so on, but we are building now. We choose to build all our dependencies on the same machine, so we don't need repository manager. We are not pushing our artifacts to a repository manager. We are just getting the final products, archiving artifacts, and that's all.
That's speed up quite big.
Sorry?
I think that's really important performance.
How do you configure your target platform? Do you use repositories in the POM or do you use target files?
We are using target files. And it's a bit long to create the library, but when you have it, after it's really fast.
So you basically get all the target platform and then put them into a zip file and then unzip. When the build time, you just unzip the target platform or you just
At build time, the target platform is not in the same machine, but in the local network. And it is available as a P2 repository. In Tyco, it's really simple to specify something locally in the local network.
So what if those external dependencies change frequently?
What?
So we have external dependencies and we use the network, unfortunately, because there are a set of common external dependencies that change frequently. So we want everyone to make sure that everyone uses the latest version of that dependency.
This is, in fact, this is not a problem for us because we are choosing one version of Eclipse in the plugins, and we are staying with them for release, and we are changing it only after each release. But if the dependencies are changing often, I think that you just need to recreate it easily. You can automate it. We are not automating it because we are changing it only each 6 months, something like that. So, or if there is a real need, we are adding something, or there is a bug fix in the new version that we really need. But if you need to take the last version every time, I think you can automate it, create a new job for it.
Get it once and use the local version.
Yeah.
So one easy question: which Tyco version are you using?
The last release.
And the next question: do you already try and profile the Tyco, so the Tyco code, and see where it's spending at time?
I didn't profile it. It plan, but I only downloaded it and yes, I just look at the code, trying to understand what is happening, how it is working. I submitted a little patch about for performance that is reported by Sonar, Victoria, about using hash map and so on. But yeah, didn't that time. Someone want to do it? Please work. Another question? So thank you very much.